Okay,
Getting up.
sure. So,
Sure.
yeah, hey everyone. Today, I'll be the interviewee, and Dave is going to interview me. So let's see, how I will do on this problem. Okay, go ahead.
Okay.
I'm scared. Okay,
Okay. So, okay.
nervous
I think,
actually. Yeah.
yeah. Okay. So the question is that you are given a hexadecimal number
Okay.
and you want to swap the bytes of the hexadecimal number. So let's say that you are given an example. Uh, you can take some hexadecimal number, let's say dead feed or something,
Okay.
dead beef, and then what you convert it into is 0xEF. So whatever the least significant byte, you put it into the MSB byte, right?
Uh
And
huh.
then so on. So EF, BE, AD, and DE, right?
Okay.
Yeah.
Hmm. All right. And this number will be like how long? 4 bytes, 2 bytes, 6 bytes, n number
You
of
can
bytes.
consider, you like, for now you can consider it to be 32 bits, so 4
Okay.
byte. Yeah.
Okay. So this is 4 byte number.
Hmm.
Okay. Fair. So because I have to kind of, this is like a mirror image, so to speak, but at the byte level,
Right.
correct?
Yeah.
Okay. So, well, this is like multiple mirror images. That is what I'm able to. So first
Hmm.
we rotate around this, and then this should give us some something like so,
Hmm.
right? And then we do mirror image around like the 2 bytes, right, at the center of 2 bytes, and then this
Right.
should swap the D on the other side. Well,
Hmm.
this effectively would be what we get.
Okay,
So,
that's interesting.
right. I mean, I'm just thinking in terms of that. So I'm supposed to then perform swaps,
Hmm.
but at different powers of two. So
Right.
okay. So if I have 4 bytes worth of data, which is the current state or the current assumption, then I flip it at the 2 byte boundary, swap it around, and then individually I swap those at a byte level boundary.
Hmm.
Correct. Okay. Okay. So let me then, start by actually, I would want to kind of return an unsigned int, and then also take in unsigned int, and let's say original number. So, or I'll
Hmm.
just say original hex, or better this way. Okay, so
Okay.
I have original hex, and what I'm going to do now is, um, hmm, interesting.
And why did you assume that you are given unsigned int? Like, is there any specific reason behind it?
Oh yeah, so I anticipate that I'll need to do the left shift and the right shift operations, and
Hmm.
what I don't want to happen is I don't want sign extension to happen,
Ah, right.
right? So what I don't want is when, let's say, the 31st bit is set to 1, and when I
Hmm.
perform like a right shift on it by 2, I don't want this to happen, right?
Right. The number
So
would
on,
completely change.
yeah, so I want this to happen. So this will happen in case of like an unsigned integer.
Hmm.
Right? So that
Right.
is one reason why I chose it to be. And also in this case, I'm really not bothered whether the number is signed or not. I just want to play with the bits, right?
mm,
And in that case, again, going back to the sign extension, to avoid that, I primarily used unsigned.
okay,
uh, and then if I were to use std int dot h, for example, then I could just maybe make it this way, which kind of also conveys the size of that integer, that
right.
it is an unsigned 32-bit integer that we are talking about.
Mm,
um, all right, so now what I want to do is somehow break this original hex at the 2 byte boundary,
mhm,
right? So I'm going to first hard code everything that I plan on doing, and then find out if there are possible optimizations. Fair.
mhm,
So I'm going to again use uint32t, temp1, and let's say uint32t temp2,
mhm,
and let me also set both of them to 0, right? And then what I'll do is I'll take, actually I can name this upper half, and then name this lower half, right? So I can then say the u half equals my original hex shifted to by 16 bits. Then I get the 16th bit down to the 0th bit. So essentially this dead uh, would be what is stored here,
mm,
right? And then in the lower half, what I can do is I can take the original hex and then maybe and it with 0xFFFF.
mm.
So in the upper half, I should have, you know, dead. Oh, nice.
Yeah,
Uh, and in the lower half, I can have beef. Okay, good.
yeah.
What I can now do is, okay, here's my plan. So if I were to now, take the lower half and OR it with the upper half, and I need to make some changes here, right? I can 32t, you know, new hex, and I can set that to 0. So what I can do is I can compose my new hex, and that can be my lower half shifted by 16 bits ORed with my upper half, right? So this gives me kind of this, right? But then I now have to flip it at 2 byte boundary, sorry, 1 byte boundary. I have to flip it here, here, and here. Is this making sense, or am I confusing you?
Uh, I think so far, yes.
Yes. Okay. Okay. Perfect. So what I'm now wanting to do is, if I can somehow flip at the byte level boundary upper half and lower half, and then simply perform this, then I would have EF and A. So I would have done this if
Right.
I swap this at byte level. So I'm now
Mhm,
going to try and do that.
mm,
So I'm going to take the upper half and shift it by 8 bits, and then OR it with upper half. Well, I'm shifting it by 8 bits, and I'm going to So and it with hex ff. So I have like shifted the first byte, so to speak, to the right, and
Mm-hmm.
then I've taken the lower byte and isolated it, and then I shift that by 8, right? So I would have effectively swapped the 2 bytes, and then I can do the same for. Let me just write this down first. I think it will work, but let's see.
Yeah.
Right? And this should give me this. So what's happening is at this point, oh, actually, let me put it here. And so I would have transformed this into hex ADDE
Mm-hmm.
and transform this into beef into EFBE, right? And then I'm just simply kind of merging both of them,
Mm-hmm.
right? Okay, so I think this will solve our problem, but only
Mm-hmm.
solve it for 32 bits. And also somewhere I do see that there is a lot of ugliness here,
Mm-hmm.
so we
Okay.
can improve that.
Okay.
Um, I okay. Let's see. Let me try and optimize this. Um, okay.
Mm.
What I can see happening here is this mask I can dynamically generate.
Okay.
Let me actually think. I do anticipate that there can be like a for loop be used here, because we are running the swapping operation, so to speak. Um, and then the mask can be dynamically generated. Well, the other thing I can do right now is take this,
Mm-hmm.
right, and substitute it everywhere that there is u half.
Mm-hmm.
So, for example, if I were to do it directly here, then okay, it becomes complicated. Never mind. The readability will get screwed. Well, all of this can translate into like one nice line. That, that's
Mm-hmm.
what I'm able
Okay.
to see.
Okay.
Right.
I'd say that you are going in a good direction, I guess.
Yeah. What I see happening is I can take the two half, swap them out first, then take the lower two halves and swap them out again. Right. Something
Right.
of that nature. If I can do in few lines, I think that would be a clean solution.
Mm-hmm.
Um, but let me think through it. Okay. So how would I do this? Mhm. Isn't this is this an Indianness thingy also? Maybe not.
Maybe
What
not.
is it?
Yes. Yeah. No.
Let me think. Definitely in my head right now, what I have is the problem seems like half, then sub halves,
Mm-hmm.
but I'm not able to imagine as to how I can do it in one shot. Um, Not one shot per se, but less lines of code, less ugly than what it
Yeah.
is, right? Okay, let's see original hex by 16. Okay, or with original hex moved by 16, because I lose the upper 2 bytes.
Mm-hmm.
Here's a hacky way of doing it. Okay,
Yeah.
so this is first solution, and obviously this is not too great, but let me propose another solution, which is, let's see if you like it.
Yeah, of course. Like,
Okay,
let's
so
see, what you're thinking.
sure. So uh, so I'm going to have an array which is of 4 bytes, right?
Mm-hmm.
And what I'm going to do is uh, assign byte access. Well, arrays cannot be assigned, so let's forget about that. I need like a, yeah. So, sorry, yes. So I'm going
Mm-hmm.
to have a character pointer, and I'm going to say that this byte access is pointing to the address of, uh, oh god, hmm, nah, man. Okay, why not? Let's see. Original hex. So wherever original hex is, I'm going to point there, and then let's say you in 32 underscore t, new hex,
Mm-hmm.
right? So, all right. Uh, the so what I'm wanting to do is, uh, at a byte level, copy the content of the integer
Yeah,
in the right
I
order.
know. Yeah.
Okay,
Yeah.
okay, perfect. So, okay, original pointer then points to original hex, and the new pointer points to the new hex. Okay, and because we are wanting to invert, what I'm going to do is, okay, I'll shift original ptr plus equals, well, actually, let it be. I'm just going to, for u int 32 underscore t I equals to 0, I less than 4, I plus plus. So what I want to now do is, the new ptr, so some indexing of this gets the original ptr, some indexing of this, and at the end I just written back the new hex, right? And I have to do few clever things here. So obviously the zeroth entry of this should be the third minus I entry of this.
Mm-hmm.
So zeroth entry here, so for example the zeroth entry here would be, wait, what did I do? Oh,
Nothing.
sorry, zeroth entry here would be the third entry here,
Mm-hmm.
right? So 3 minus 0, then first
Mm.
entry would be the second entry,
Yeah.
second entry would be the first entry, and third entry would be the zeroth entry.
Yeah.
Okay, I guess pretty much solved. Well, one other thing I can do is maybe use size of operator here. Or length equals to size of original hex, whatever that happens to be. This just to avoid magic numbers.
Mm-hmm.
So I take the length here, length, and then length, and then we make this pretty I plus plus. So this is good. Mm, yeah, pretty much done.
Uh, can you check the line number 29 again? I think you just
Sure.
replaced a number.
Replace a number.
You just replaced a number with a length.
Yes.
Does that seems
Length.
correct to you?
No, 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 no. Sorry. So this has to be length minus one.
Mm,
Wait, actually, hang on. So the length here would be four. I'm taking
mm,
in three here,
mhm,
but actually, let's not fiddle with this. Let's
mm.
actually do the right thing here. Minus one.
Yeah.
Yes. Thank you. Yes,
Okay.
that was an important observation.
Mhm.
Cool. So yeah, done.
And here
Mhm.
also, I think you are using some sort of pointers and
Mhm.
some external memory. Maybe just
Mhm.
can you think of replacing the byte by byte? Maybe take the one byte, try to
Sure,
replace
sure.
it. Yeah.
Sure. So byte by byte. Then are you suggesting that I modify the original hex itself?
Right. Yeah.
Okay, okay. So the way I would want to then do it is, you know, take a pointer to the original hex,
Hmm.
and then
And maybe
well,
like somewhere
now,
copy down there, and then
hmm,
this
understood.
is a nice solution I want to have.
Okay, okay,
I
okay.
want to keep
Let's.
it.
Okay, fair,
Yeah.
fair. Let's go here. So you're suggesting that I can reduce the memory usage now.
Hmm.
So definitely, I would want like a pointer to that original number.
Or maybe not the pointer. Maybe you are getting the integer itself.
Okay,
Yeah. And then now you
okay.
want to modify that only.
Oh, okay. And then I can return back that
Right.
number
And
itself.
true. Okay, fine.
Well, see, that is tricky. Is it tricky? Well, sure. Let's see. So original pointer, I get rid of all of these, right? And then I do address of original hex, right? And this goes away. Um, I want to keep the length. Can I use a character? Can I use one byte, or do you want me to not use that?
Yes, maybe just one byte
Okay,
external memory, and then if you can solve that problem with this one byte.
sure, sure. So then, what this will boil down to is that I kind of store this value here first,
Mhm.
or actually not. So I will first store the zeroth value, retain that. Following that, replace the zeroth value with the. So I'm wanting to use this variable to hold on to the value while I'm doing like the swaps, right?
Mhm. Okay.
So I'm going to hold the ith value and then swap the ith value with the len minus 1 minus I value,
Mhm.
right? So at this point in the first run, okay, obviously, then I also want to change this value. So this I use temp, and I'm also seeing that if I can throw in XOR somewhere here, it would be, I can eliminate this variable also. But let's see if I
Mhm.
get to that. Right. So I hold the first, like the zeroth. Let's say I hold DE here, right? Then I go ahead and put like in place of DE. Uh, well, I put EF here, and that EF comes from here, correct? So this EF is now put in this place. Okay, and then I like erase the EF here and put the temp value, which happens to be DE, right?
Mhm.
Okay, and then after that, when I is 1, so I'm taking 1. Okay, I need not run it this
Yeah.
long. This will only run like 2 times.
Hmm.
which makes it even more.
Maybe
So does
length by 2 or something.
yeah, I was
Yeah.
thinking of that. This runs half the time. Okay, I want to take a stab at going ahead and eliminating this as well.
Okay.
Okay, and the logic that I'm able to think of is, um, if I were to swap A and B, then A equals to, oh, I don't know, man. A XOR B, and then B equals to A, and A equals to, I have no idea. Just I know that if I cleverly XOR, the temp would be not required, right? So
Okay.
let me think.
Okay. Interesting.
Yeah. So so the thing is, if okay, here's what I'm thinking. All right. So if we have X equals to A XOR with B,
Hmm.
and I XOR with A again, then
It
this
should
will
give you
equal to
B.
B. Fair.
Yeah.
So my intention then is, if I can if I can assign B the value of A XOR B,
Hmm.
right, then the XOR of A and B both are retained here.
Right.
And then if I assign A the, well, B is, nope, sorry. Let me think. I think I'm close to saving one byte. Okay. Okay.
I think
Uh,
at this point A is not modified, right? B is modified.
B is
A,
modified, A is not modified.
yeah.
So I have to use the unmodified A to extract out.
With B, maybe.
Yes. Yes. Correct.
Yeah.
But okay, after this, if I assign A equals to B
Yeah.
XOR with A,
This
then
should
I
give
have,
you a, yeah.
oh, B's value is in this.
A.
And now if I do, oh man,
Yeah.
oh, wow. Okay, wait, at this point, this is AB mix.
Yes.
So mix, right? And
Yeah.
then when I say, wait, what?
This is A and B, and you do
So
again
B
with,
is mix. So
yeah.
from the mix, if I XOR with A, this becomes B.
Yes.
Now B is extracted out. So I take B is, oh, okay, okay. A is now
A is
B.
extracted out. Yeah.
Okay, okay. This is confusing, but I think we get it. So
Yeah.
if I, all right. So, oh man, this, okay. Let's see if I can, execute this maneuver correctly. So let me just copy this and paste it right here. So I'm going to take this very cleverly and XOR it with this. So this was my B. Now I'm supposed to take this, which was my A, and equate that with, whoa, very clever, man. So, oh, actually, same thing written twice. Okay, and what is my B, which is this, and then essentially, am I not performing the same XOR thrice?
Uh, what do you mean by same XOR?
Like if you see the XOR operation here, it's always happening between A and B. Right?
Yes. Yes.
So
Yeah.
this is what it is, except it's like B A B. This is my
Yes.
B. This is my A. This is my B. This goes
Yeah.
away. Right. This. Oh, whoa, 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 whoa. This goes away. Yeah, okay, fair. This is the solution. Okay, do you
Man,
see? Oh wait,
yeah,
I have to return original hex.
yeah,
Yes, okay, yeah,
yeah. I think nice set of solutions, man.
yeah. Did
Yeah,
not anticipate, but
yeah.
yeah, I'm feeling nice.
I think the last solution is kind of out of box because uh, it's really interesting to figure out this way. Uh, like
Well, but
personally,
I'm.
we don't
Uh-huh.
think in that way, right? Like, okay, maybe we would use some sort of shifting and then pushing it back to those bytes, right? To that
Hmm,
integer. But
hmm.
this is out of box, man. Yeah,
Well, I think this is also somewhere luck because
yeah,
I had seen the swap of values
yeah.
using
Two
XOR
integers
earlier.
maybe. Hmm.
Yeah, and I saw the
Yeah.
opportunity of adding that in here.
Hmm.
Cool. Yes.
Yeah. I
Feeling
think
very nice.
yeah, yeah, feeling nice maybe. Yeah.
Okay.
So I think I wanted to give you some feedback here.
Okay.
That I think all the solutions are, man, amazing. What I feel is that you should not always stick to a single solution. You should
Hmm.
have
Hmm.
multiple solutions where
True.
you can have a trade-off between those solutions, right? If you just have one solution, then you are forced to implement that, right?
Hmm.
Having
Hmm.
multiple solutions gives you choices, and one of them will perform better and one of them will perform worst, right?
Hmm.
And then you can choose which one you want to use, right? For your
Okay.
given use case, right? Then I think there is a second thing, that you have been using these readable variable names. I think most of the times what we do is we use a, b, c, I, j, k, right?
Right.
And that doesn't make the code readable. Someone outside of uh, like your team, if reading those code,
Hmm.
they won't understand because what is ing and what all the other things, right?
Hmm.
I think initially you started with hard coding the numbers,
Right.
uh,
Yes.
right? And I think if you take that as a brute force, that's fine. But if
Hmm.
you end up using only that solution, then it's very limited, right? You can only do 32-bit. You cannot go
Right.
more than 32-bit, right? So interesting. This seems to be a divide and conquer, right? You are dividing
Yeah.
for 16 byte, and then you are going ahead and dividing for
Hmm.
8 bits, right?
Hmm. Hmm.
So that seems to be a great way to solve the algorithmic problems.
Hmm.
Yeah,
Well, as you were speaking about divide and conquer,
right.
I was also thinking of that. Let's say if we were to allow, you know, we were to allow for pointers and
Hmm.
this was to become void, then this returns nothing.
Hmm.
And if we also then, gave in, let's say, the size,
Size, yeah,
right? I think this can then be made generic,
right, yeah.
right? And something here would change. The
Hmm.
length wouldn't be this, but well, the length would start off as uh,
Size, or maybe
size,
yes, size
yes,
only, yeah.
and or actually this would also, well, I can
Mm.
make this as length, and we can get rid of this. Uh, but now what I can do is I can say length divide equals 2.
Okay.
So what I'm thinking of is, let's say the length was 128,
Hmm.
right? So we are short, like we are less than 128. So zeroth element is replaced by the 128th number,
Hmm.
127th number.
Okay.
Then we increase this by 1. So 1, and we are replacing 126th. No, I think this would still stay length by
Yeah, length
2,
by 2.
and
Yeah.
this would still be.
Hmm. And then
Yeah, I
maybe
think
you
so.
don't
This
give
becomes generic.
another pointer here, the original pointer.
Mm,
Yeah.
well, that's coming. Okay, I think
Ah,
this
okay.
is.
You changed it to character. Okay.
Yeah, yeah.
Yeah, okay. That sounds good.
This would be a generic solution. Yes.
Yeah. Yeah. Okay.
Yeah, I'm feeling
Shall we
very
wind it up?
nice. Yeah, yeah. Let's do that.
Yeah.
Do you have any more? Well, I wanted to write this solution down here, just
Hmm.
because, you know, we talked about the brute force solution, and it was kind of limited because of these numbers, and masking was limited to 32 bits, right?
Hmm.
Then I kind of moved it up a little bit, improved it a little bit.
Yeah.
I think this was also nice.
Hmm.
And when we moved to this, it was like, okay, still for 32 bits, but with 1 byte. So here I
Yeah.
was wasting how many? 4 bytes for this. Another pointer should be like 12-ish to 8 or 12
Hmm.
bytes.
Hmm.
Then we go down here, down to save 11 bytes here, and then, you know,
Yeah.
use no more than absolute minimum.
Hmm.
And then here, I think, we just make it very clean.
Yeah.
Yes, I think I'm happy.
Okay.
Perfect. Okay. Um, Thanks for joining in, folks, and we'll catch you next time.
Yeah. And if you have any different solution, maybe post in
Yeah.
the comments. Yeah. Okay.
Yeah, definitely. Take care. Bye bye.
Okay. Bye bye.